Hello everyone, this is our next video of Fortinet series, and the today video we are going to discuss NAT mode, transport mode and VLANs on the Fortinet firewalls. So we will discuss what are the use of NAT mode, what is the use of transport mode. We will understand the two scenarios of the VLAN on this video. So let's begin the video. So first one is the NAT/route mode. So some people will say this will be the NAT mode, some people will say this will be the route mode. Both are the same. The FortiGate or VDOM is installed as a gateway or router between multiple networks such as the private networks and the internetwork. The function of NAT router is more to allow FortiGate to hide the IP address on the private using NAT. And NAT/route mode can also be used to connect to the multiple ISP using the SD-WAN setup and to route traffic between the networks. So let's understand what is the scenario of route mode or NAT mode. Let's say this is your FortiGate firewall, and now here we have a ISP, means that internet provider, and on this side we have the LAN users. So this will be the LAN users. So we on the LAN side definitely we have some private ranges. I can take as a 172.16.00 I would say, and in the private ranges we have some 101.192 and so on 00 kind of that the public ranges. So what NAT/route mode supported? The first, it supports the routing. So we can see that we can assign the IP addresses on the FortiGate firewall on the both side, and we are already aware that to move the LAN users towards the internet we need a NAT. Why we need a NAT? Because the private ranges cannot travel on the internet. Both are two different ranges. So private ranges IP address cannot travel to the ISP internets. So we will translate this private ranges to the public ranges. That process we called as a PAT or static net. So multiple terminologies is there, but the concept is the translation will happen. So those functionality is available in the route mode only. So also we can also say that in the route mode we have the VPN functionalities. So all the layer 3 functionality, I will say the layer 3, the IP address functionality is available on the route mode. And this is the widely used in the most of the organization, NAT mode or route mode. So let's move to the next discussion, that is the transparent mode. The transparent FortiGate VDOMs operates in the layer 2 forwarding traffic. So just I confirm you that NAT mode supports layer 3 traffic and the transparent mode supports the layer 2 traffic. So between network devices such as router and switches. So in the transparent mode to a network, it only need to provide with the management IP. So it is the mandatory thing. If we are configuring the FortiGate firewalls in the transparent mode, so the management IP is a must thing. So without management IP we cannot configure the transparent mode. If you try to configure the transparent mode without providing the management IP, you will get the error. And I will show you the in upcoming lab sessions that how we can configure the transparent mode and other things. So let's back to the video. So in order to access that, why we need the management IP? So management IP is needed to access the FortiGate firewall for the management purpose. So it is recommended that a dedicated interface is used to connect the management interface. So it is like a recommendation that we have to use the dedicated management interface for it. So I have one diagram. So if we see, this is our management network. So means the network engineers are here. They are using these PCs to access this FortiGate firewall for policy enforcement or any kind of changes on the Fortinet firewall. So here we have the FortiGate firewall. This is our FortiGate firewall. The layer 3 addressing is available on the routers. The switch will send the traffic to the router, and in between that, this FortiGate firewall will work. So in case of transparent, there is a no assignment of the IP address. We can place the FortiGate between the your internal network to external network. So we can see that this is our external network, I would say. So because the ISP is connected directly to the router, and this is the LAN side of your internal network. So we will place the FortiGate here. So we will take a one cable and connect to the FortiGate, and from switch side we will take a one cable and connect to the FortiGate. So here we will take one cable, and here we will take a one cable. So the traffic initiates from the internal range. It will go to the router. In the between this, FortiGate will come for the policy enforcement. So let's say that FortiGate will see what is the source addresses, what is the IPS, IDS, and other things. The FortiGate will verify, and after that they will forward to the router, and then it will travel to the internet. And please note that here the router is doing the translation of the packets, means the private ranges moving towards the internet. These all translations will be done by the router only. So let's start the other topic, that is the VLAN. So VLAN multiply the capability of FortiGate, can provide the multiple network security using VLAN tags, logical separate devices on a network to a smaller broadcast domains. These smaller broadcast forwards package to only the device part of domains to reduce the traffic and increase network security. So many of us, we know that the basic functionality of the VLAN to reduce the broadcast domain. It improves the network security, as well as that it also provides the scalability of the network. That is the reason we are using the VLANs. So FortiGate Pro also supports the VLAN tags. That switches are also sending traffic with the different tags. That is all supported by the FortiGate. So, and why we need a VLAN? So VLAN is used to reduce the broadcast domain and divide the network into the smaller broadcasts, so that we have some improved network security, better management control, and also scalability is also available, segmentation of network is available. So multiple advantage of VLAN is available. So how we configure VLANs on the NAT mode? The FortiGate unit as a layer 3 device. So we understand just now that we have two modes, NAT mode and transparent mode. So layer 3 device means that it is on the NAT mode. So in this mode, FortiGate units control the flow of packet between the VLANs and can also remove VLAN tags from incoming VLAN packets. So that in the case of NAT mode, FortiGate is having capability to remove the VLAN tags which is coming from switches. The FortiGate unit can also forward untagged packets to the other network. So the packet will come on the FortiGate, it will remove the tag, and then it will forward to the internet. The FortiGate unit supports VLAN trunks, IEEE 8021Q compliant switches and routers. So 8021 is a standard, that is controlled by this is the IEEE standard. So most of the switches are compliant with this standard. The trunk link transport VLAN tagged packets between physical subnets or networks. When you add a VLAN sub interface to the FortiGate physical interface, the VLAN have IDs that match VLAN ID. So we understand that VLAN have one tags that tag is known as the VLAN ID, like 10, 20, 30. The FortiGate unit direct packets with the VLAN ID with the sub interface matching addresses. So the FortiGate will forward the packet using the sub interfaces, VLAN sub interfaces. So this is the one diagram for the VLAN in NAT mode. So we have this internal switches, and we have this VLAN 100 and VLAN 200. Those are the different ranges, and they are connected to 0/3 and 0/9. And we have one trunk link which is connected to the FortiGate. And after that, the VLAN 200 is trying to access the internet. Then FortiGate will remove the 200 tag when it's going towards the another interface, forwarding towards the internet. So I can show you one quickly that how we can create this kind of VLAN tagging. So we will take one interface. Let's say we have a like a 3 VLAN tags. So I will take, in this example, I'm taking the port 2 of my FortiGate VM. What I will do, I will create a new sub interface that we known as the VLAN tags. Here I will say VLAN/10. So this is the VLAN 10. I am going to apply for port 2. So this port 2 will connect it to the switch. So in case of real environment, it will connect it to the switch. So if I want to enable any administrative access, we'll discuss about it in the upcoming videos. But now, if we want to enable that ping and HTTPS, we can enable it. So by default, they're creating an address also. That is also, if I disable it, they will not create. But for now, I'm enabling it. We have option to assign IP address, and definitely we will assign. Okay, now creating. So in the physical port number 2, we have a virtual interface, that is a VLAN 10. So in the VLAN 10, we can assign the IP address of the VLAN 10 range. So if I take as an interface, here I will say VLAN 20. So I will create a 2 interface. You can create like as so much needed. So I will map the port 2 only, and here I will type that VLAN ID means we also see the VLAN tags. Here we have to define the IP address of the VLAN 20 and click it. So now this port 2 will connect to the your physical switches. So we have already added that all VLANs on this port 2. That's the reason from switch side we have to make the trunk. So that switch will forward all VLAN traffic to the FortiGate firewall, and FortiGate is having all understanding of the VLAN tags, and that tags are associated with the physical interface. So that's the quick like a demonstration on the FortiGate VM. So let's now back to our slides. So this is the physical switch. This is the physical switch we just created, or this is we can take any Cisco session whatsoever on. So the users are in connected with these different ports. So this port 0/3 will be the part of VLAN 100, and 0/9 it is the part of VLAN 200. So this 2.0, so I just show you that in the case of FortiGate, we will assign the sub 2.1 on the VLAN 200 sub interface. So where we will assign this 2.1, if I go here, let's quickly it VLAN, let's say VLAN 100. So here we have to assign the 10.2.1.1 kind of that, then /24 or whatever it is. So this is the gateway of your PC or end devices. This is the gateway to reach this VLAN. So just like a similar kind of structure in the Cisco side, we known as the SPI. The another topic will be the VLANs in the transparent mode. So we understand that we can create a sub interfaces on the FortiGate side that known as the VLAN tags. But in the case of transparent mode, So we have some kind of different configurations. So in the transparent mode, the FortiGate units behave like a layer 2. We understand from the transparent behavior that this will be the layer 2, and it will only perform the security functions. And some limitations of transparent mode that we understand, any layer 3 functionality or feature will not available, like SSL, VPN, P2P. These are the layer 3 functions, NAT and traffic, because there is a no IP address configured on the FortiGate. So how we will perform in the case of layer 2 or the transparent mode? So this is the VLAN router and this is the switch. So the FortiGate will be the between this. So we have to define, let's say this side, internal side, we have to define the VLAN 10, and external side we have to define the VLAN 10. So this is with the two interfaces. So one interface will be the part of 10 and another interface will be the also part of 10, so that the LAN side traffic will come, it will match for the VLAN 10 tag, and now it will reach to the router for the VLAN 10. So let's quickly, I can show you this on my whiteboard. So what I want to say, so let's say this is our FortiGate and now this is our Cisco switch. Give me a minute. This will be our Cisco switch, and now we can drawing some kind of that, and this will be our Fortinet or firewall. So this will be connected to this, and here we have a switch that is known as your external switch or layer 3 switches. So all the all the end pieces are behind of this switch. So this will your LAN, and this this device is still in your environment, but for the designing perspective this will be your WAN, because we need to create a policies also defining the interface level. So this interface we will assign on the VLAN 10, and this will be the also VLAN 10, and here we have the also VLAN 10. Why both sides are VLAN 10? Because the traffic will initiate from this switch and it will travel like this. It will be traveling like this, and go to this WAN switch. So that VLAN tag should be present on the ingress and egress level of the FortiGate firewall. Otherwise, if you don't have that VLAN tag, it will not forward it. Untagged packet will not accepted by this WAN, or it could be the any layer 3 switches. So this is the major difference between the designing in the case of transparent firewall or in the case of the NAT modes. So let's back to the video. Yeah, so in the case of NAT video, so this was the video related to that VLANs and the transparent and the tunnel mode on the FortiGate firewalls. So I hope you enjoyed this video very well. If you enjoyed, please hit the like button and subscribe the Firewall Experts for this kind of videos. Thanks for watching Firewall Experts.